So here we are with the 2-4 assignment. We're going to work through some long division and synthetic division and that. Alright, so in number 3, they want you to divide f of x by d of x. So in number 3, I'm going to take f of x, which is x cubed, and then divide it by d of x. Which means that out front of my long division, or actually synthetic division because it's x plus 3. Let's do that, it's faster. So in number 3, the little number that's going up here is going to be a negative 3. Remember, it's the opposite of what we see here. And then all of my coefficients, let's see, we have a third power, second power, 1, and number. So we'll have a 1, a 4, a 7, and a negative 9 as my coefficients. And then we can do the synthetic division. So again, the reason I chose synthetic division was because there is a 1 out front of our divisor. And so it's a linear binomial, and so we can use long division, or synthetic division, which is the faster one. So we bring down our 1, and then 1 times negative 3 is negative 3. And then we're always adding these pieces in here, so we're going to end up with a 1 again. And then 1 times negative 3 makes negative 3 again. And so 7 minus 3 makes 4. 4 times negative 3 makes negative 12. And then negative 9 plus negative 12 makes negative 21. And so officially that means that our equation has now been reduced to an x squared instead of what it originated as of an x cubed. And then we have 1x, and then 4 as our constant, and then our remainder is negative 21 over x plus 3, the divisor. So the two things that they want you to do is to write a summary statement in polynomial form. Again, this is the answer. But they are going to give you two factors or two types of answers. But the idea is that one of them takes the time to rewrite your original equation. So f of x is actually equal to the answer that we got, which is x squared plus x plus 4 times our divisor, and then minus the remainder. So that's going to be your polynomial form. And then the rational or fraction form is that we took f of x and divided it by x plus 3 and ended with x squared plus x plus 4 plus, minus 21 over x plus 3. And 3 without trying to, the arrow key is right there. Okay, so I'll put it, oh my gosh. Anyway, there, plus 3. So, again, only really need the thing that's in the yellow circle there. Okay. So the next one, number 6, if we are dividing that, this is not a linear binomial, and so we do have to use long division. So when we use long division, you are going to want to insert a 0x in here because otherwise you're not going to have each of the pieces each time. So you can, once you get into the swing of it, do it without having each of the pieces, but if you're just starting out or remembering this process, you don't really want to skip stuff. So this is the very long polynomial that we are then going to be dividing by x squared plus 0x plus 1. So the first thing we do is figure out how to get from x squared to x to the 4th. And so we're missing an x squared in order to then be multiplied by each of these pieces. So x squared times x squared makes x to the 4th. X squared times 0 makes 0x cubed. And then x squared times 1 makes 1x squared. Then we're going to go ahead and subtract each of these pieces. So we'll get 0, which is what we want. The next piece is going to leave us with negative 3x cubed, take away nothing. And then the last one is going to be 6 minus 1, so negative 7x squared. Then we bring down our next piece because we do need a trinomial since we are dividing by a trinomial. And so now we're just trying to find out how do I get a negative 3x cubed from just an x squared. So what's missing is a negative 3 and then at least one more x. Also noting that this column is the x column, this is the x squared, and this is the number column, so really it could only be an x up here. Alright, so now we multiply as we did with the other one into each of these three pieces. And so we're left with negative 3x squared, because of course we want it to be the same, and then 0x squared, and then negative 3x. And we are going to subtract each of those pieces. So officially this becomes 0. The next piece is just staying negative 7x squared. And this last piece becomes negative 3 plus 3x. So we actually get 0 x's. And then bringing down our last one, we are now trying to divide everything in here to get a negative 7x squared. So what we're missing is a negative 7. And so if we multiply that into each of the pieces on the other side, we're going to start subtracting 7x squared, and then also a 0x, and then a negative 7. And so if we complete that, and of course I'm running out of room, we're going to end up with negative 7 minus 7x, and so that's 0. 0 minus 0, so that's 0 again. And so we really just have a remainder of negative 2. A remainder of, because we're subtracting. So 5 minus negative 7, meaning plus. So a remainder of 12. Alright, so finding out that we have a remainder of 12, which I'm looking at this, and they don't have that in the answer key. X squared minus 3x plus 5. Oh, Lord, all the way back up here was supposed to be different. Okay, so up here, turns out that 6 minus 1 is actually not 7. I'm going to do a completely different color so that we can see. Let's see, I'll do purple. Okay. So it turns out that 6 minus 1 is 5, and then 5 minus 0 is actually 5 again. And then we're going to do 5x, so we actually need to change this into 5. And then we distribute the 5 and get 5x squared plus 0x plus 5. Which, when we do it, oh my gosh, is a remainder of 0. Wow. Okay, so all those purple pieces we're having to fix a little bit. Okay. Oh my gosh, I made a mistake. Okay. So in that case, our answer is going to be this piece up here. But of course, if you really want to take the time to write it in polynomial form and fraction form, be my guest. But I'm just looking for the result. So x squared minus 3x plus 5 for number 6. Then we move on, and we're going to use synthetic division and write a summary statement in fraction form. So really we're just going to say equals and what it actually equals. So when we do some synthetic division, I need to take this factor and do its opposite over here. And then I look for every leading coefficient, even though there isn't one for a constant, we do need to have that. So we'll have 9 as our leading coefficients, 7, negative 3, and 1. Then we're going to do the process of synthetic division. So we bring down our 9. 9 times 10 becomes 90, and then we'll add that, so we get 97. 97 times 10 becomes 970. This is really ugly. Oh yeah, this is it. And so then we get 900 if we add these, and 67. And then 967 times 10 is 9,670. Add that to 0, and we still get a remainder of 9,670. That's gross. All right, so our official result then is that we get 9x squared plus 9x plus 967, and then our remainder of that 1,000 number over x minus 10. So we get to say that it equals, again, 9x squared plus 97x plus 967 plus our fraction of 9,670 over x minus 10. It's a really ugly answer, but that's our answer. Sweet. All right. The next one has x to the 8 minus 1. And so as we're going to divide, and we are using synthetic division, in our k value up here, we're going to have negative 2, because that's the opposite of a positive 2. And then all of our leading coefficients, I'm actually going to move this over since we have a lot, are going to include x to the 7 and x to the 6, etc. And so we're going to have 1 for x to the 8th, but then x to the 7th is 0, and 6th is 0, 5th, 4th, 3rd, squared, 1, and then finally to our constants of negative 1. So, doing some synthetic division, I'm going to bring down the 1 and get 1 times negative 2, which is negative 2. Add that to a 0 and get negative 2. Then negative 2 is going to be multiplied by negative 2, and so that's going to get us positive 4. And then 4 added to 0 is going to leave us with 4. And then 4 times negative 2, oh my gosh, keeps going, so negative 8. Add that to 0, you get negative 8. Negative 8 times negative 2 gets you positive 16. Positive 16 plus 0 is 16. 16 times negative 2 for the next piece is negative 32. Add that to 0, it's still negative 32. Negative 32 times negative 2 makes positive 64, and that added to 0 is 64. 64 times 2 gets you what, negative 128? And so negative 128 plus 0 is negative 128. Times 2, we're almost there, is a positive 256. And 256 with a combination of negative 1 leaves us with our last number of 255. My pen just turned off. 255. All right, and so officially our answer is going to be all of these with their x's. So 1x to the 7th minus 2x to the 6th plus 4x to the 5th, and so on and so on. So our official answer, if I write it over here, 1x to the 7th minus 2x to the 6th plus 4x to the 5 minus 8x to the 4 plus 16x to the 3. Continuing on down here. Minus 32x squared plus 64x minus 128 plus 255 over our divisor of x plus 2. Yuck. Again, answer. They're not always pretty. All right. Let's see, moving on to 13 through 18, we're going to use the remainder theorem to find the remainder when f of x is divided by x minus k. So again, they tell us what our k value is, which is the thing that would go into this piece here, also meaning that the factor is x plus 3 if we wanted to reference that. So let's see. We have all the powers, so we're just going to use the coefficients of 1, negative 1, 2, and negative 1. And then we're going to do our synthetic division. So 1 goes down and makes negative 3. Those added makes negative 4. Positive 12, so 14. 14 times negative 3 is something. Negative 42. And so negative 43 is our remainder. And so because we have a remainder, that's all they're asking, so we know that that's not a factor of that polynomial, but either way, negative 43 is our remainder. Boop. Alright, then in the next one, if we do some division, we're going to get a remainder as well, so let's see what that is. Our k value again goes into that little box, so we have a negative 1 of the factor that's actually coming from x plus 1. Our leading coefficients are 1, negative 2, positive 3, negative 20, and 3, and none of those are missing any powers, so 1, negative 2, 3, negative 20, and 3. Alright, so if we do our strategy, we're going to get negative 3, and add that and get 6, add that and get negative 26, add those and get 29. I'm missing something. Yep, missing something because it turns out that I am missing the power of 3 here. Wow. Lame, I thought I checked it, but I didn't. So there's a 0x to the third in there that's making this not possible. Alright, so I'm going to do it over here because I have one more term and I don't think it's going to fit. So we have a negative 1 up here and then all of the coefficients. So 1 for the power of 5, negative 2 for 4, 0 for the power of 3, 3, negative 20, and then 3. Okay, so now it's going to work because we have all the powers taken care of. So bring down your 1, negative 1, perfect, add them together, woohoo. Negative 3, 0, woohoo. Negative 20 plus 0 is negative 20, and then 20, so 23 is our remainder. Yes, it is. That's a bad 23. Having issues on my iPad writing 2's. We'll go with it. Alright. Next one, we're going to use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. Okay. So the factor theorem is technically the remainder theorem, and we're just trying to find out if the remainder is 0. And if the remainder is 0, then it's a factor, otherwise it's not. So, since both of these in these problems are linear binomials, we can go ahead and do actually, I'm not going to do long synthetic division. I'm just going to plug in the number. So the number I'm going to plug in this one is 2. It's the opposite of the factor. And then in this one, it's negative 1. So all I need to do is plug in f of 2 into this equation. So 2 cubed plus 3 times 2 minus 4. And hopefully I get a 0. Let's see. 8 plus 6 minus 4, definitely not going to be 0. So it's apparently 10. Alright, and so because 10 is not 0, we can conclude that x minus 2 is not a factor. Alright, let's try plugging in negative 1. Oh, sad, the answer key is up on my computer and it's also a no, but let's plug it in anyway. Alright, f of negative 1. If we plug in a negative 1, wow, to the 10th power, okay. Oops, that's supposed to be a 1. Okay, so this first term, 2 to the negative 1 to the 10th, well, any negative to a positive power, an even power, is going to be a positive number, so 1. So 2 times positive 1 is 2. Perfect. Then to that, we're doing this one, so negative 1 to the 9 results in negative 1, and then we're making that negative 1 a negative, so plus 1. This next set, negative 1 to the 8th, is an even power, so we're going to get a positive 1. Negative 1 to the 7th power is a negative power, so we'll get negative 1. And let's see, negative 1 to the 6th makes it positive 1, so 2 times positive 1 is 2. So lots of fun stuff here. 2 plus 1 is 3, plus 1 is 4, minus 1 is 3, plus 2 is 5, minus 3 is 2. And it turns out 2 is not 0, and so again, x plus 1 is not a factor. And again, because 2 is not 0, which is what we would get if there was a remainder of nothing, meaning it divided nicely in. Alright, moving on to number 27, we need to find the polynomial function with leading coefficient 2 that has the given degree and zeros. Okay. So as we did in our previous assignment, if this is the 0, then the factor is x plus 2. Same with the next one. If that's the 0, then the opposite is its factor. And then in the last one, the opposite of 4 is its factor. We don't necessarily need to take the time to rewrite this so that it's in expanded form, because this is going to be it with just those zeros. I boxed that too soon because notice that it does say leading coefficient of 2, and so that means that I would need to put a 2 out front, because if I multiplied x times x times x, I would only get x cubed and not 2x cubed, which is what they want. They want a leading coefficient of 2. So in that case, I'm going to put a 2 out front, and then I'd have my answer. And you can also kind of double check that by actually factoring this out if you would like with the box, and then realizing that you need a 2, so multiplying that out front. Alright, the next one has a degree 4, and then it mentions 4 zeros, so that's helpful. So looking at each piece, x minus 3 as a factor is actually x plus 3. Oh, that's an ugly 3. Oh my gosh, I keep making it worse. Okay. Plus 3. Still worse. Okay. And then x plus 1 for the next piece. Technically, the next one is x plus 0 or minus 0, but that's not changing. But that's not changing anything, so really, it's just x. And then the last one, if you don't want to get too creative, is just x minus 5 halves. The way the book will write this one is as 2x minus 5. The way they get that is because if this was equal to 0, you'd add a 5, right, to both sides, and then you'd divide by 2, and so you'd get a 0 of 5 halves, as they have. But you can always just keep it as the fraction if you don't want to go through how to rewrite that. So officially, making this a little bit less messy, we do have all of these terms, and then, as it says in all of them, the leading coefficient of 2. So I need a 2 way out front here. So I'm going to rewrite this because usually we don't just have an x sitting in the middle, so it's going to be 2, an x next to it, and then any order I want of each of these pieces. And again, x minus 5 halves is fine, or you could do it as 2x minus 5. So moving on, now they want you to use the rational zeros theorem to write a list of all the potential rational zeros, and then determine which ones, if any, are zeros. Gross, which means we're going to have to plug them all in. Okay, so the way that we do this is we take the last number, or constant, and find all of the factors of that. Whoa. And then in our denominator, we find all of the factors of the leading coefficient. And then we put them all in their fraction form. So, from -1, the factors of -1 are going to be plus and minus 1. Those are the only numbers that could ever multiply to be -1. In the bottom, we have a bigger list because clearly 1 could multiply or divide into 6. Sorry. We could also have 2 that could multiply or divide to get 6, 3 as well, and then 6. So there's going to be a lot of options that we can actually plug in order to find out which ones become 0. All right. Since there are other types of numbers other than real, where does it say, then determine which ones are zeros, you could have rational zeros, and you could also have multiplicities. So really, it's not guaranteed that all, in this case 3 of them, are going to be in this set, but we are going to actually take the time to plug in all of the following numbers. So we're going to plug in -1/6, +1/6, -1/2, +1/2, -1/3, +1/3, and -1/6, +1/6. So these are all of the things that you need to plug in to find out which ones are going to get you a 0. So again, we're plugging them in for this x right here in order to find out if we get 0. Because if they equal 0, then we have a rational, well, we have a root that we can use, or a factor. So going on to the next page, apparently if we plug in, hey, the number 1, let's see, what number are we on, 33? So the way that I would do this other than by hand is using a calculator. So I'm going to do one of them by hand because, of course, that is how they want you to do it. So if I plug in the number 1, which is one of the options, we're going to get our first set here of 6, and then -5, and then -1. So it turns out it's 0, which means that since I plugged in a 1, that x minus 1 is a factor. It also means that 1, or, well, let's do it as a point. Okay, so again, it means that x minus 1 is a factor, or 1, 0 is an x-intercept, either way. All right, so how do you do this the cheater way? So you go to your y equals, and of course you can graph them, but we're trying to plug in each of these numbers. So instead of graphing and trying to find a window that works, you're going to go to your y equals and type in your equation. So let's see, 6x cubed minus 5x minus 1. And then if you go to second graph, the second button and then the blue graph button, you're going to end up at your table. And depending on who used your table last, you can actually set it up, because notice that we have a bunch of fractions, and of course your table is probably going by ones. So if you actually go to second window, where it says table set, so again, this was so that we could get to the table, and this was so that we could get to table set. There, it's table set. If you go to, let's see, if you change your table setup so that it says independent, and you highlight the word, instead of auto, you highlight ask, and then you go back to the table, all of a sudden you're like, oh my gosh, there's no data. But yes, there is, because you get to type it in. So for instance, you could write 1 divided by 6, yay, and then it would tell you that it's not 0. And then you do -1 divided by 6 and press enter, and it would tell you it's also a 0. So one way of doing this a little bit easier, rather than literally plugging them in and algebraically finding them, especially with these weird fractions, is by using our calculator system here. So that's going to be it for this video, and then I'll finish the rest of the problems on the next one.